So this is the board, molecular model set. So if you look at the colors here, we have black, white, red, blue, yellow, green, purple, gray, and white. So carbon symbol C is the black color. So all these black colors are the element of what? Carbon. So it means it has 4 bonding. It means carbon should be surrounded with 4 bonds. So it has 4 holes and the geometry is tetrahedral. Now if you look at the white one, these are the white. So this white represents hydrogen, which has only one. It goes under what they call single bond. So we also have oxygen, that is the red. So the oxygen represents the red bulb. We have blue. So the blue represents the nitrogen. So this is the blue that represents the nitrogen. So it has, so for the nitrogen, it also has what? 4 holes, tetra. So you have 1, 2, 3, and 4. We also have sulfur, which is the yellow. There are different types. The other one is 4. The other one is 5. Look at here. 1, 2, 3, 4. This one. You have 2 sulfur here. The other one is 4. The other one is 6. That is under octahedral. So the green one. The greens represent the halogen. That's the group 7. So we also have the purple. The purple represents the phosphorus. So these are the links. We have 2 types here. So this one, it is the one that we use for single bond, this type, and this one are the one that we can use for single covalent bond or double covalent bond or triple covalent bond. So we'll start to build from the alkane, then to the alkene, then to the alkyne. In this demonstration or this modeling, I'm going to show you how to model the structural formula of the alkane, alkene, and the alkynes. If you can see in this textbook, you are seeing a structural formula. You are seeing here the structural formula. So first of all, you have to understand what you mean by the structural formula, molecular formula, and empirical formula. So for a structural formula, it shows what the arrangement of atoms in the molecule of a compound, and molecular formula shows the actual number of atoms present in one molecule of a compound, whereby the empirical formula shows what the simplest ratio of atoms in a molecule of a compound. So here we are not going to use empirical formula. We are going to use the molecular formula to build what the structural formula to show how the actual atoms are being arranged in a particular molecule of a compound. Yes. This is the first one that we are going to start under the alkane homologous series, that is methane. So looking at methane has only 1 carbon with 4 hydrogens. Now, based on my previous explanation that the black ball is the carbon and the white one is the hydrogen. So now we learned that the carbon has 4 bonding, single bond. It means that carbon should be surrounded with 4 bonds. Now we say these links, we have the 2 types. This one is for single bond and this one is for double or triple bond. Now let's fix our carbon here. Yeah. The second one. So you see, carbon is having how many bonds? 4 bonds. Now from there we start fixing our hydrogen. That's the white ball. So you can see now, this is the structure of what methane. 1 carbon with 4 hydrogen. So this is the molecular formula. This is the structural formula. So this is, actually what is being built. This shows the structural formula of methane, which has 1 carbon and 4 hydrogens. So the 4 hydrogens are surrounding what? The carbon. So the white that you are seeing, these are the atoms, these are the hydrogen. So the black one is the carbon. So this is the structural formula of what? Of methane. So the other one, the second one is ethane. Ethane has 2 carbon and it has 6 hydrogens. 1, 2, 3, 4, 5, 6. So we said from the carbon, the bond between the carbon to carbon is single. So we are going to use this one. We have 2 carbon there. So which means there's a single bond between carbon to carbon. Now we have 3 hydrogens surrounding this carbon. So this is our hydrogen. We fix the hydrogen there. You have our hydrogen. Hydrogen. You are seeing 3 hydrogen. 3 hydrogen are surrounding this carbon. Another 3 hydrogen also surrounding this carbon. So this is the structural formula of what? Of ethane. That is, it has 2 carbon and 6 hydrogen. 1, 2, 3, 4, 5, 6. And the bond between the carbon to carbon is what? A single bond. So this is the simple model that you can use to teach your students on the structural formula of alkane. So here, this is ethene. Ethene, the bond between the carbon to carbon is double bond, and it has also 4 hydrogen. Ethene has 1 double bond, and also it has 4 hydrogens. Each of the carbon is having what? 2 hydrogens. Now let's see how we are going to build this structure. Now this is the carbon. This is also another carbon. We have 2 carbon. Now we also have a double bond. So let's fix the double bond here. So this is the double bond between the carbon to carbon. Now from there, now it has what? Each of the carbon is having 2 hydrogens. Now we fix our hydrogen. So this one is having 1 hydrogen, 2 hydrogen. So it also has 2 hydrogen. So you are seeing here now in this structure, this is the double bond. This is a carbon. The black one are the carbon, and it has 2 hydrogen. This is the hydrogens. So it means ethene has the carbon to carbon bond is double bond, and it has 4 hydrogens. So this is the structural formula of what? Of ethene. The first one was ethene. Now the second one is prop-1-ene. So prop-1-ene means there are 3 carbons here. The first carbon and the second carbon is where you have the double bond. Do I see here? 1-ene. 1-ene is where the double bond is. So it has 1, 2, 3, 4, 5, 6 hydrogens. So now we are going to build this structure now. The first one is the first carbon, and there's a double bond between the carbon, the first carbon and the second carbon. So we have our double bond there. So this is the double bond between the first carbon to the second carbon, and also there's another bond between the second carbon to the third carbon. So we remember we said that each of the carbon should be surrounded with what? 4 bonds. The first carbon, where the double bond is having 2 hydrogens. So we are going to fix our 2 hydrogen there. So you see, so we have 1 bond, 2 bond, 3 bond, 4 bond. Each of the carbons will have what? 4 bond. 1, 2, 3, 4. So now here we have 1 bond, 2 bond, 3 bond, and 4 bond. We have a 1 bond, 2 bond, 3 bond. Now it left with 1 bond. Now each carbon should be surrounded with 4 bond. So So we have here now 1, 2, 3, 4. So this one also is having what? 4 bond. Now the last one has 3 hydrogens. So we have here 1, 2, and 3. So we have 1, 2, 3, 4. So it will have what? 1, 2, 3, 4 bond. So this is the structure of prop 1 in 1, 2, 3. So it's prop 1 in. So it means in the first carbon, that's where the double bond is. So this is the structural formula of prop 1 in. So the last one for the alkene, here we have one substituent there, that is chloro. So now here we have 2 chloro but 2 in. It means at the second carbon, that's why we have our chlorine. In the same carbon also, that the second carbon, that's why you have our double bond. So the structural formula is having 4 carbon and is having a double bond between the second carbon to the third carbon, and also a chlorine with the second carbon. So we are going to build this structure. Now first, now we have 1, 2, 3, 4. We have 4 carbons. So this is the 4 carbon, 1, 2, 3, 4. Now here, at the second to third carbon, that is from here to here, we have double bond there. So which means we are going to have our double bond here. We fix it here. This is the double bond now. So you see, this one is going to be 1 carbon, the second carbon, the third carbon, and the fourth carbon. So between the second and the third carbon, we have a double bond there. So this is what you should do for the first step now. But also in the same second carbon, we have halogen there, chlorine. So now we fix our chlorine there. We say that the green atom represent what? The halogens. So we have our chlorine there. Now the first carbon is having what? 3 hydrogen, 1, 2, 3. Now we fix our 3 hydrogens there. So we have 1, 2, 3 hydrogen. The third carbon also is having 1 hydrogen there. And also the last one is also having 3 hydrogens there. So look at here now, we have 4 bonds here, 1, 2, 3 bond surround this carbon, 1, 2, 3, 4. Here the same thing, 1, 2, 3, 4, 1, 2, 3, 4, this carbon. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. So this is the structural formula of 2 chloro but 2 in. So alkyne, it has what? 3 double bond between the carbon to carbon. Now here we have the first carbon, the second, the third, and the fourth. So now it means now at the second carbon, that's where you have our triple bond. So now the name is but, which means 4 carbon. True ine, it means at the second carbon, that's why you have the triple bond. So this compound is called butyne. So we are going to build the structure of this compound butyne. We have 4 carbon there, 1, 2, 3, 4. So let's first fix that one. So this is the 4 carbon present in butyne. But in the second carbon and the third carbon, between them there is a triple bond. So which means we are going to fix triple bond in that compound. This is 1, 2. Now we have here now triple bond 1, 2, 3. The triple bond is between the second carbon and the third carbon. So we say that each of the carbons should be surrounded with 4 bonds. 1, 2, 3, 4. So this carbon have 4 bonds. 1, 2, 3, 4. 4 bonds. Now here we are having extra 3 carbon hydrogens here. We have our hydrogens here. So this is butyne. It means it has 4 carbons. From the second carbon to the third carbon, we have there a triple bond, and it has also 1, 2, 3, 4, 5, 6. It has 6 hydrogens. So this is the structural formula of what? Butyne. So the last structure that I will build is benzene. It has 6 carbon, 1, 2, 3, 4, 5, 6, and also 6 hydrogen, 1, 2, 3, 4, 5, 6. Now, this carbon to carbon, there's a double bond. This carbon to carbon, single bond. Carbon to carbon, double. Carbon to carbon, single. Carbon to carbon, double. Now, let's fix that now. First. So this is how the structure look like. 1, 2, 3, 4, 5, 6. Now between these 2 carbon there is a double bond. So we add 1 double bond there between these 2 carbon. Double bond. This carbon to this carbon there is a double bond, single bond, double bond, single bond, and another double bond here. So this is the structural formula of benzene. So you can use this to teach your students. So thank you very much for your time and liking this channel, and please subscribe for more tutorials to come on chemistry at aladichemistry.com.